All right, here we go with the more challenging problems in 5.9, solving by factoring. Okay, so let's go ahead and title our notes 5.9, solving by factoring, part 2. And we're using the zero property, solving by factoring, part 2. All right, so we did 4 examples in that first video, so let's go ahead and continue on with example 5. Let's go ahead and solve. And suppose that I have this one. 3x plus 1 squared equals 6 times 3x minus 1 plus 3. Okay, so yeah, not as nicely set up as the other examples. But so all you have to do here is multiply these out. Okay, so multiply out. Okay, and then set it equal to 0. Set equal to 0. And then it'll be back to the more simpler type of problem. Okay, but here you do have to do the multiplication. All right, so hopefully you remember how to multiply this quickly. If not, then you're going to have to go off to the side and do this and do your distributive property. Do 3x times 3x, 3x times that, 1 times that, 1 times that. Okay, I'm not going to do that. I'm going to use the shortcut that I taught you guys. So here, this is going to give me 9x squared plus 6x plus 1 equals, distribute the 6, so 6 times 3 is 18x. 6 times negative 1 is negative 6, and bring down the plus 3. Okay, so 9x squared plus 6x plus 1 equals 18x. Negative 6 plus 3 is negative 3. Okay, all right, so I've simplified this. I multiplied it out. I simplified each side. Now I'm going to set it equal to 0. So I'm going to go ahead and subtract 18x on both sides. I'm also going to add 3 on both sides. And that way these cancel here and I get my 0. Okay, so let's see what we get on the left side. 9x squared, negative 18 plus 6. Okay, so that is negative 12x. 3 plus 1. Okay. All right. Do they have anything in common? No, they don't. Okay. Let's see. I'm going to try 3. Because these are perfect squares, that's a perfect square and that's a perfect square, I'm going to try 3x's. Both sides have to be negative. And I'm going to try 2 and 2. Whenever you see that pattern, then try the square root of 9, square root of 4. Okay. All right, let's see. Do we get our negative 12 for the middle? Out here, I get negative 6x. In here, negative 6x. That gives me negative 12x. And my middle term is negative 12x. Good. All right, so this works. I'm going to erase that. Okay, so then once you, again, let's go back to the original problem. Multiply that out. Again, if you don't remember the shortcut, just do it this way. Because remember, exponent is repeated multiplication. Distribute, simplify, combine like terms. Get it equal to 0. So do the opposite operation. Subtract 18x on both sides. Add 3 on both sides. These will all cancel, giving you the 0. Factor. Now you can take each factor, set it equal to 0, and solve. 3x equals 2. Divide both sides by 3. X equals to 2/3. Or this other factor. Oh, actually, it's the same factor. So you don't have to do it again. This is a repeated solution. Okay, so since they're both the same, 3x minus 2, 3x minus 2, of course you're going to get the same answer. Okay, so this is a repeated solution. Okay, so no need to do that side. Okay. All right, let's take a look at this one. Again, this next one is worded in a strange way, so it'll throw students off. But let's take a look at it. Okay, so it says let f of x equals, it's still a solving problem. So let f of x equal x squared minus 71. Okay, and then it's going to say for what values or value of x, in other words, solve for x. What values of x is the function equal to 10? Okay, so for what value or values of x is a function equal to 10? Well, here's your function, and we want to know when does this equal 10? So let's do that. Let's go ahead and set it equal to 10. X squared minus 71. We want to know when does that equal 10? Okay, so that's what all of that means. Here's your function. Solve for x so that the function equals 10. Here's your function. It equals 10. Now let's solve. We want 0 here. So the same solving process still applies. You want it to be set equal to 0 before you start factoring. Okay, so let's go ahead and subtract 10. That way we get our 0. All right, so we get that. Perfect squares. So that's easy. X plus 9, x minus 9. So x plus 9 equals 0. So subtract 9 on both sides. X equals negative 9. Or, these are not the same, so you do have to do this one. Add 9. X equals to 9. Okay, so don't be afraid if you see one of these questions on the test and it's kind of written out all weird like that. It's still a solving problem. Your function equals 10. So take that function, set it equal to 10, right? In other words, substitute. Replace the f of x with 10 because f of x equals 10. So replace that with 10. Okay, that was example number 6. Let's take a look at this next one, number 7. Let's go ahead and solve this one. 6x cubed minus x squared equals 2x. All right, so again, we don't have it equal to 0, so let's subtract 2x. Put it in order. So 6x cubed first, x squared next, and then minus 2x, and we have our 0. Okay, so here they actually have x in common. So let's do our common factors. So they have x in common, and that's about it. And then I get 6x squared minus x minus 2. And now that looks like our traditional quadratic trinomial. Okay, so let's go ahead and factor that. Bring that x down. That x is part of your answer. Okay. All right, so let's go ahead and let's try 6. This one might take a while. Okay. And then different signs to make negative 2. And then negative 2. No, that's not going to work. negative 2 and 1. I can't put a 2 there. Okay, so that's not working. All right, let's try 3x and 2x. Okay, and I don't want the 2 there. I'll put the 2 here and the 1 here. All right, let's check the middle. Let's see if that works. Okay, let's just double check. 3x, 2x, that's 6x squared. 2 and negative 1, that's negative 2. Now let's check the middle. That gives me negative 3x. That gives me positive 4x. And together that gives me positive 1x. What do I want from the middle? I want negative 1x. So let's change the signs. That's having the wrong sign, but the right number is easy fix. Just change the signs. All right, so this one needs to be negative, and this one is positive. Okay, and then here you actually have 3 factors. So a lot of people forget this one here. So don't forget this one. Okay, wherever you see an x, you're going to have an answer. Okay, so here, x equals 0. Here, 3x minus 2 equals 0. And here, 2x plus 1 equals 0. There's no work on this one. We're done. But this one, add 2, divide by 3, x equals 2/3. This one, subtract 1, divide by 2, x equals negative 1/2. Okay, so negative 1/2, if you can't tell. Okay, so you have 3 answers here, 0, 2/3, and negative 1/2. So that's why I have this one here, because too many times people forget that. Don't forget that x, okay? All right, and then let's do this one here. Example 8, solve. And suppose that you have this, negative x to the 4th plus 5x squared minus 4 equals 0. This one is quadratic in form, okay? All right, so let me bring this down. So we can still do our factoring here. But instead of x times x, we're going to be doing x squared times x squared to make x4. All right, but I like this. I prefer this to be positive, so I'm going to go ahead and multiply everything, both sides, by negative 1, and that changes everybody's sign. Okay, so x to the 4th minus 5x squared plus 4 equals 0. Okay, so all I did here, was I multiplied the entire equation by negative 1. Okay, changing everybody's sign. All right, and then here I can factor, but I'm using x squared times x squared. That way I get the x4. Signs have to be the same. They're both going to be negative. It's not going to be 2 and 2. Looks like it's going to be 4 and 1. And that actually gives me negative 5 for the middle. Okay. Aha, but look at here. We have perfect squares, difference of squares, difference of squares. So we can factor some more. So this one is going to be x plus 2, x minus 2. And this one's going to be x plus 1, x minus 1. And so now, just like up here, we had these 3 factors, right? Down here, we have 4 factors. So this one, x plus 2 equals 0. This one, x minus 2 equals 0. This one, x plus 1 equals 0. And this one, x minus 1 equals 0. So we have to solve all 4 of them. These are all easy, though. Subtract 2. Add 2. Subtract 1. Add 1. Okay? All I did was subtract 2 on both sides. But I do this in my head. These ones are easy. Okay. All right. Okay. One more example because we need to flash back. If you're watching this video on a Thursday, we're going to do a throwback Thursday. All right, so let's solve this one. X cubed minus x squared minus 9x plus 9 equals 0. All right, so anyone recognize what kind of factoring you're going to be doing here? You better have said grouping. Okay, you're going to do factoring by grouping. Do you remember that? Here, I'm going to go ahead and write it down here again. Okay, so remember, this is one group, so ignore them. This is one group, and do common factoring. They have x squared in common, so I'm going to factor out x squared, and I'll have x minus 1. Okay, then over here, bring down the sign, and now ignore them. This is your second group, and they have 9 in common, so we're going to factor out a 9, and I'll have x. Remember, you have a negative 9 out here, so that's going to change this sign, and we're going to have x minus 1. If you do this correctly, these two should match. X minus 1, x minus 1, they match. So I'm going to factor that out. And the second factor will be what you have out here, x squared and minus 9. But we have difference of squares, so we can keep on factoring. So let's factor some more. So perfect squares, so that's going to be x plus 3, x minus 3. And then we have these three answers because x minus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. And if we solve each one, x equals 1 here. Subtract 3, x equals negative 3 here. Add 3, x equals 3 here. Okay, so that is it for the more challenging problems, but I hope you understood everything here. If not, make sure you email me, make sure you text me. Use your study groups to post questions there. Look in the discussion section once in a while to see if anyone has posted anything. Help each other out. Okay? All right, I'll see you next time.